Hello and welcome to this episode of T-Tech. So today we're going to talk about TOR Basics. So essentially what TOR is. So TOR is actually a proxy, is essentially what it is, but it deals a lot with anonymity and a little bit of privacy, those two things. So the TOR stands for the onion router, so it's actually sometimes referred to as onion routing. And the TOR protocol was started as an idea around the 1990s, and after that time, after it was initially developed, the TOR project was founded in 2006. And what they wanted to do was make sure TOR stayed around as a program and was able to flourish and get more worldwide support. But the main objective is keeping internet communications anonymous as well as secure. So that is the main objective of TOR, or the onion router. And there's many implementations of TOR and different ways you may use it. Now, I will also say TOR is also cross-platform. So you can run it on the BSD operating systems, you can run it on Linux, Mac, or Windows. So it's cross-platform in that way, but there are a few ways to run that, and they include the TOR standalone binary, the TOR browser, and even Tails OS. So the standalone version is really easy. You can just grab the binary, fire it up, and then you tell your program to use the binary's port as a proxy. So it binds to a port on the loopback interface, and then you send traffic through it, and it becomes a proxy. But if you don't even want to deal with that, you can use the TOR browser. Now, it's plug and play for a reason. It's essentially Firefox, and what they have done, the TOR project specifically, is they have made it very easy to proxy everything that you use in that specific application through the TOR network. So that's very easy, and you don't have to think about proxy settings in that case. You just download it on a supported operating system and launch the application. Now, the interesting one of these is Tails. Now, Tails is just an operating system that is pre-configured for TOR only, but that's not all it does. Now, it also can run what's called in live mode, essentially, off a DVD or a USB stick, or even in a virtual machine. But that, when you are using something like TORs and you want that level of privacy, you actually want to run it on bare hardware. You don't want any kind of trace on that system. Even if you check out the website, there's emphasis put on that as well. So you can run it on there and it's in RAM, and then when you turn it off, everything is gone. So that is the three main ways at least to run it. And I also want to add, you can also build it from the source code, of course, if you're on an open source operating system. Because, Windows and Mac, I do not believe you can build it from source code. But for anything privacy, it's always important to build it from the source code if possible, if you want the highest level of assurance that the program isn't tampered with. So how TOR operates, big picture. We know ways we can run it now. Basically, all it is up here we are the client, and that it could be whatever, essentially it's whatever application we're proxying through TOR, whether it's the browser, whether it's the standalone binary, or even Tails. And what we have is just our layer 7 protocols, whatever our payload is. And what we do is route the traffic through to a TOR guard node. And in this case, our ISP is what we call the public internet, essentially. And TOR, you can think of it kind of like a VPN or even an SSH tunnel. It's an overlay network on top of the public internet. All right, so when you're using TOR, the ISP doesn't see that TOR is the connections between TOR itself inside of the network. Those are logical between the nodes, and the nodes communicate between each other using public networks all over the world. So you first connect in through the ISP to this guard node, and then you have the middle, and then you have the exit, and then you have another ISP, and then that's how you access the server. So the flow of that communication looks like this. It goes from node 2 to node 4 to node 8 in this case, and then exits out to the server through whatever ISP they have. Now, any part of this can be filtered by the operators of the relays for the exit nodes. So your mileage may vary with different applications, but just realize that the node operators are in full control of that. And your ISP can see you are connected to a guard node, just like they can see you're on an SSH tunnel or a VPN. So essentially, once that takes place though, the only thing they can see is this first connection, and once it goes through the network, you've achieved anonymity, because N2 only knows you connected. But once it sends it to N4, he doesn't know where the traffic came from, or even where it's going to. What TOR does is builds a circuit when you start the application. This is that circuit. This could be any random group of 3 TOR nodes. All right, and one of them, the exit, is the actual proxy. The relays are what get the communication of TOR to the next relay in the network. So that's essentially how it's sent around, and that is what a TOR circuit is. But how is it private in addition to being anonymous? Well, each node in your circuit has a public-private key pair, and whatever your layer 7 payload is, when you set up that circuit, you receive the public-private key pairs of all of the nodes that make up this circuit. So the public-private key pairs encrypt in multiple layers the payload. So the first one encrypts the payload, the plain text of it, even if it's HTTPS, but normally it can be encrypted already to begin with. And the second node encrypts the first node's encryption and vice versa. So it's essentially kind of nested on there. And when you send it through, the N2 in this case, the first, our guard node, he uses his private key, the private key, to decrypt that layer of encryption. So layer 1 of the encryption on the payload is off of there now. And when we go to N4, he takes off his layer of encryption with his private key and setting up the circuit. Again, you get copies of the public keys for the nodes in the circuit. So when we get to the last one, he takes off his layer of encryption, and then he sees layer 7 payload. So you can see as well, that's why we have anonymity, because only N2 knows you're connecting to it. We already have anonymity from N2 to N4 because he doesn't know where it came from, only that it came from N2, not from you. And it's also encrypted at this point, so he can't see the payload. And once it gets to that last one, he just takes the last layer of encryption off of it and then connects into that server. So that's how it's working. Now, very important with TOR, don't do anything that you don't log into any banking sites or any things you wouldn't do on a proxy. You don't want to do anything that you may not want people in the TOR network being able to sniff, because anyone in the world operates these, and there isn't necessarily that trust there. So don't share any personal credentials or anything. That is not a good idea. That's a good way to get hacked and things of that nature. So one thing with TOR though, because the ISP knows you're connecting to a TOR node, sometimes they just prefer to block it, and they will just have an access control list for that traffic. But what if you need to get through that? Well, that's where you have bridge nodes. And bridge nodes in the TOR network essentially run on normal service ports, and they look mostly like a normal service. And the big thing is they're not actually listed on the circuit list database, like the nodes in TOR. They maintain a database of when the nodes are up and down and the speeds they are supporting and things like that. The bridge nodes aren't listed there, so it's more challenging to block bridge nodes. And there are some countries where this is actually really important. But that's why that's there as an option. What it goes through though the same way, essentially, and that is how you get through there. It's just a small detail where it's not listed on the database. Now you can choose this, by the way, when you use the application, the TOR browser or Tails and the standalone binary. But if you cannot connect to TOR normally, you will know immediately if you need the bridge node. Now, the last thing is actually really interesting. These are called onion addresses, otherwise known as hidden services. So this is an extra layer of anonymity for the actual resource you're trying to access. Because I want you to realize this portion in the middle, whatever provider networks are connecting it, could be in universities or data centers. These nodes can be anywhere as servers, physically connected. The server, though, and you are on the public internet. Same thing with all the ISPs and everything connecting it. But that does mean when you connect to the server, that is seen, and everything can be, it's public when you connect. It can be seen, and there's also timing attacks and things like this, because TOR is obviously not perfect, and nothing is. But with these hidden addresses, it tries to move the server into the TOR network and essentially not really assign it a domain name or anything like that. But again, there's timing attacks for this as well. So it's essentially it's as good as what the protocol is becoming. It's a very interesting experiment how they're developing it. But you can combine that with a bridge node if it's blocked as well. And the biggest reason for using these, actually, things like YouTube and other websites that are on the public internet also have onion addresses. You can essentially connect there with no one seeing, except obviously the TOR service, but you have anonymity and that encryption. But that is what I wanted to get across there with hidden services. So in this next quick part, I'm just going to show you the websites where we can find TOR, Tails, and the TOR browser. So I will see you in a second. Alright, this is the torproject.org website. Now, this is essentially where you can get all the news about TOR, you can donate, and things of that nature. Now, this is essentially the mission of the TOR project for the most part. Now, here's where you download TOR Browser. If you just click that, you can download for Windows, Mac, Linux, and even Android. But you can also download for BSD either from the ports collections of those respective operating systems, or you can click and download the source code. And when you do that, then you can either download the TOR source here, but you can also get the Windows Expert Bundle with just TOR, and that's essentially the standalone binary. That's the TOR browser, and now I'm going to quick show you the Tails OS website in 1 second. Alright, this is the Tails website, and again, it's a portable operating system for the same reasons. And you can look here and see how Tails works. This is what I was trying to say. It runs in RAM as a live USB or live CD. And essentially it's able to make it so there's no trace on your laptop. And when you shut off, it's all in volatile memory, and then everything is gone. So from there you can get Tails for Windows, Mac OS, and Linux. Same thing here, or you can just download them directly. If you do download the USB image directly, right from here, you would just use Etcher or just the DD command and things of that nature. I believe on Windows you can use Etcher or Rufus on Windows as well, but understand though, you have to shut off Windows if you're on it and boot up Tails if you are using, this method. All right, so that is the basic idea of what we got going on with TOR. And again, I do want to say this as well. TOR, when you hear the term the dark web on, name your favorite show on Netflix or whatever else you watch, this is the dark web, so to speak, is just those onion addresses for the most part. So that's where you want to stay away from, by the way. I would never recommend just browsing around on it. Alright, so as an example, on Linux Mint here, I've downloaded the TOR browser and extracted it. And you just want to double click the folder here and then double click TOR Browser. And pretty much this is identical for Windows as well. And what you do from here is normally you'll just hit connect or just check always connect automatically. Now if we do this, if you think back to the diagram, connect will just get us to the first guard node in the public TOR list, and then we'll start our TOR circuit from there, get our public keys that we talked about, and be able to proxy everything that this browser connects to through TOR. We can also, though, choose to go to TOR network settings, and it didn't always used to look like this, by the way. It may just be Linux is a little bit different than Windows, but I haven't used this in a long time, so. From there, though, we can always connect automatically. We can use a bridge here if we check this, and then select bridge or anything like that, and those kinds of settings. But again, in my case, it's not filtered, so we're just going to connect, and it's establishing a connection, and it will connect in a second or so. Again, these could be very dispersed around the globe, so the round trip times and latency the packet's experience is a lot different. Now, what we'll do is, first thing you'll notice, if you try to go to Google, most times anyway, it is not going to appreciate it because it's going to think you're some kind of bot or something, and other things like that. But you already see, though, it's not in the English language. And the reason is because this exit node I'm using in this specific circuit isn't in my current location. I'm not connecting to Google as I normally would. Same thing if we go to duckgo.com. Alright, another good way to check that TOR is working, but it will be if you have it on the TOR browser here. We're coming out of Germany at the moment. And we can check and make sure the browser is configured to use TOR. And again, that's the IP the website is seeing. But another interesting thing about TOR is that if you're using different applications, sometimes those applications will send your real IP address from that client on your real network. So that's why you have to be so, if you actually want anonymity, you need to be careful how it's configured. And that's why the websites mention that. But essentially that circuit, if you want to change it for any reason, let me see up here, maybe they have it. Right here. So normally this just shows you connections here in normal Firefox, but it shows you our TOR circuits. So this is our guard node. This shouldn't change, by the way. And then we're going through another circuit in Germany and then in Norway. But remember, those circuits, those are the only things they actually see. They're using underneath public networks in the world. So that's how it can still be monitored and things of that nature globally. So it's definitely not perfect, but for certain situations where you want anonymity and privacy, it's a pretty good thing, and it's a good thing to understand how to use. So with that, though, that's a little bit about TOR. And again, if I want to do a new identity for the site, I just click this, and it will reload that website. And what we just did was get new public keys from these two nodes that are new. The guard node shouldn't change, as you can see. But that's essentially how it works. So again, with that is a demo of the TOR browser. Again, please use it responsibly. That is all I will tell you. Do not do anything you wouldn't do on the normal internet on TOR with this tool if you're just learning about it for the first time. So with all that, it's Tyler with T-Tech. I do hope you enjoyed this video, and have a very nice day.